Yesterday we started to look at how to create equations of lines if we were given a graph of a line on the Cartesian plane, and today we're going to review the ones that we did not go over in class. You were to do them on your own. Some of you were helping people out, which is awesome, and we're going to review those right now before we turn them in. So let's take a look at number 4. Number 4 was one that we did not do, so we will investigate it very quickly. Number 4, if we take a look at it has two distinct things we need to find if we're going to graph the equation or write the equation for this particular line on the graph. You need a slope, which is always denoted by the variable m, and a y-intercept, which is denoted by the variable b. Y-intercept, when you're given a graph, is super easy to find. It's always the point at which that line crosses the y-axis. So our y-axis is the vertical axis. The point at which it crosses happens to be right there. It's between 3 and 4. It happens to be 3, or sorry, between 2 and 4 happens to be 3. There we go, misspoke. So our b, which is our y-intercept, would be 3. It's a positive 3. And then to find the slope, again, you need two distinct points. I'll go ahead and pick a few. Here's a distinct point. Let's see, another distinct point. Boy, hard to find. There's actually only one other distinct point that you could find on this graph. Happens to be right there. Some other points are very close to being distinct points. However, there are only two. So those are the two you would have to use on this one. I'll go from my far left point, which is over here, and we will try to then find the rise over run, which is our slope. We'll go ahead, we'll have to rise, which means we'll have to go up 1, 2, 3, 4, 5. When we go up, that's positive 5. Would also have to go to the right, that's positive as well. Would go 1, 2, 3 to the right, positive 3. So our rise over run for our slope would be positive 5, I'll just use 5, over 3, which looks like 5/3. If you want to turn this into a mixed number, stop yourself, because it will not look as pretty, and it will not be as easy to then graph points later if you use a mixed number for your slope. So just leave it improper. It's okay, not a big deal. We'll remind ourselves that y is equal to mx plus b is our general form for a line in slope-intercept form, and we'll just plug and play at this point. It would be y is equal to, and then whatever our m is, we determined that was 5/3, 5 over 3, times x, and then b is going to be determined whether it's plus or minus by the sign that goes with our y-intercept. It happens to be a positive 3, so it will be plus 3, and there is the equation for that line. We could prove it by using one of those points and plugging in our x and a y, but I'm not going to do that for this particular problem. All right, next, we're going to go ahead and investigate number 6. So that was number 5. We did that one yesterday. Here's number 6. Number 6, we'll zoom in on it just a little bit here. There we go. All right, number 6 has a y-intercept as well. It's where, again, that line crosses the y-axis. It's hard to tell because the numbers being overlapped by the line, but it would be at 2. So our y-intercept is 2. We still need to find a slope because you have to have both things to have a slope-intercept form equation. And so I'll identify some distinct points. There are more on this one. In fact, there are 1, 2, 3, 4, 5 distinct points that we could use. It does not matter which two you use, but you have to pick 2. I'll go ahead and use my y-intercept, and I'll use the next point from it. Rise over run, I need to go up, that's positive 1. Need to go to the right, 2, positive 2. 1 over 2 is the slope, or rise over run, so it would be 1/2. We remember that y is equal to mx plus b, so that means y is equal to 1/2 x, and then 2 is positive, so it would be plus 2. There we go. I apologize for the sloppiness of my writing. All right. Next, let's look at number 7. I'll zoom in a little bit farther this time so we can see more of what's going on here. Here's number 7. Lovely. We need a slope and a y-intercept. Slope m, y-intercept b, and y will be equal to mx plus b. Okay. Y-intercept, easy to find, happens to be right there at 4. So that's our b, positive 4. And we need to find some distinct points to find the slope. So I'll go ahead and mark some. There's one. There's one. There's one. And you might not see it right away, but there's one also. Pick any 2 of them. I don't care which 2. I'm going to be a little wild and use my far extremes. And we'll have some huge numbers here, but it will simplify down to be the same slope that most of you got. So we'll start on my far left point, which is the farthest one down. I need to go up. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Positive 9. And to the right. 1, 2, 3. Positive 3. We end up with a rise of positive 9. That's 9. A run of positive 3. That's 3. 9 over 3 simplifies to 3 over 1, which is just 3. And we would pop that into our equation. Y equals slope 3. X. B is positive 4 plus 4. And let's go ahead and prove this equation. I'm going to pick one of those points that was on that line that I identified as a distinct point. So let's say, let's look at a point I did not use, which would be that one. That happens to be at an x value of -2 and a y value of -2, so -2, -2. I will pop those x and y values into my equation and see if it holds true. Y was -2 is equal to 3 times x was also -2. 3 times -2 plus 4. All right, let's go ahead and simplify. -2 is equal to 3 times -2 would be -6 plus 4. Well, that -2 still stays the same. -6 plus 4 is -2. Is -2 equal to -2? Heck yes, it is. So that means we had a good equation. Good to go. And lastly, but not leastly, that doesn't really make sense, last but not least, number 8, we have a y-intercept. This y-intercept happens to be crossing through the origin, so the y-intercept is 0. I'll write that down. B equals 0. And we'll look for some distinct points. There's one. There's one. There's one. I don't care which ones you pick. I'll use that one and that one. Rise over run. Down 1. -1. To the right, 1, 2, 3. Positive 3. Rise over run. Slope m equals -1 over positive 3. So -1/3. Y equals mx plus b. Y equals -1/3 x plus 0. And this is one of those equations that you could also write it another way if you wanted to, and it would be written this way. Y equals -1/3 x. The reason we could write it that way is because the plus 0 is not affecting the value. If you got at least to that point, y equals -1/3 x plus 0, stay there, you're good. If you try to simplify it and you're messing up, then don't worry about it. Just leave it -1/3 x plus 0. That's fine.